Hello dear students of class 9, how are you today? You're doing excellent, I hope so. Children, I want to share something today. Being a school teacher, I love to see you all practicing a lot of mathematics. Practicing maths gives you joy. Every sum that you do gives you a sense of accomplishment, isn't it? And that is why you even enjoy practicing it more and more. Well, children, the same practice is missing in physics. Just by learning question answers or theories, it is not going to build interest in physics. You need to solve numericals and learn the concept through the problem solving, and then you will enjoy it even more and more. So in today's session, I am presenting the solutions of periodic test 2, and the numericals are from chapter motion of class 9. So students, those who are watching this video from the other schools, it is must for you all to pause the video here, take a screenshot of the questions, take 20 minutes to solve these questions, and come back after 20 minutes to watch the solution of the questions. So if all done, let's get started with the solutions of these 4 questions. So question number 1 is an assertion reason. How do you solve questions based on assertion and reason? Let's see the question over here. The question is, assertion says velocity is a vector quantity, and the second statement says velocity changes only if there is a change in the magnitude of speed. Well, children, how I solve any assertion reason question is like this. I read the statement like this: velocity is a vector quantity, and I solve it as a true and false statement. So you have to see whether this statement is true or false. Well, this statement is true, as you know. Velocity is a vector quantity because it has both direction and magnitude, or magnitude and direction. So it's a quantity that requires both. Just by giving the magnitude, you cannot describe velocity, and just by direction you cannot describe velocity. So both the quantities are required. For example, if I write here, let's say 40 meter per second, I need to mention direction. Let's say it could be east or west or anything, right? So here direction is very important. Now the second, so this statement is basically true, so I'll write here true. Now the second statement says velocity changes only if there is a change in magnitude of speed. Well, this is not true because it's a false statement. Why? It says only if. Well, the velocity can change if there is a change in magnitude or there is a change in direction, or both. So if any of the quantity changes, either the magnitude or direction, the velocity is going to change, and that is why the second statement is false. Now here, if one statement is true and the other is false, this is a very easy option to choose. From here you can say assertion A is true and reason is false, so option C is the correct answer. I hope you have got it right. Now let's move to the next question, number 2. The question number 2, it's a question based on average speed. How do we calculate the average speed of the vehicle? So I'll read out the question once. The question says a car moves at a constant speed of 60 km per hour. This is a constant speed here. You must check here. It's a uniform speed. It's a constant speed. Uniform speed of 60 km per hour for 15 minutes, and then at a speed of 40 km for next 15 minutes. Calculate the average speed of the vehicle. So here if I see, in the first interval the car is moving at a speed of 60 km per hour, and it is moving for 15 minutes, right? It moves forward for 15 minutes. and in the next interval it is moving at a speed of 40 km per hour, and it moves for again 15 minutes. Well, you can see in the diagram I have shown the first interval a little longer than the second one because the speed is more, so it will be covering longer distance than the second interval, right? Now we need to calculate the average speed. Children, you all know the formula, right? This is from the theory. You all are now very much familiar with the formula. The formula is average speed. I must write a little on the right side. I'll write over here. Average speed is equals to, you know why I'm leaving the space. Average speed is equals to total distance covered by total time taken. So I'm calling this distance as d1 and I'm calling this distance as d2. And well, this time I am calling it as t1 and this time I am calling it as t2. So here average speed is equals to d1 plus d2 divided by t1 plus t2. Okay, so how do I find distance d1? Well, often children, what they make mistake is they simply write the speed like 60 plus 40 divided by 15 plus 15. Well, if you are one of them doing this, know that it is physics, and physics always the values come up with the units. They are not just 60 and 40. It is 60 km per hour, 15 minutes. So you have to be very, very careful in physics, because these are not just numbers 60 and 40, they represent certain quantity. Here 60 represents a speed, not the distance, and that is why if you are writing 60 plus 40 and divided by 15 plus 15, this is absolutely wrong. Okay, so we need to find distance d1 here. So what is the distance d1? Here you can see the speed is given over here, the speed is given and time is given. So from here we can calculate d1 in fact. So d1 here will be speed into time, and since it's a constant speed we can apply the formula like this, s into t. So this is 60 km per hour and time here is given in minutes. So you see the problem over here. If I write a time here 15 minutes, now we cannot multiply 15 again with 60. Why? The problem is with the units again. You can see the speed is expressed in kilometer per hour. So hour represents the time and 15 minutes also represents time. So we need to convert this into hour before we multiply the two numbers. And this is again where children make mistake. They do not convert the units properly. So this is 60 km per hour multiplied by, this is 15. You can in fact convert here itself, and this will be like 15 by 60 r, and that is equals to 1 by 4 r. So you can directly write over here, this is 1 by 4 r, 1 by 4 r, and now you can see here this unit hour and hour can be cancelled out, and the answer is left here as 60 by 4, that is 15, and the unit will be kilometer, which is correct. So you get the d1 as 15 km. Likewise you can calculate d2 also. So d2 will be equals to, the speed is 40 km per hour and time is 15 minutes again, which is equals to 15 by 60, and that is equals to 1 by 4 hour. So here if I write here s into t, the speed will be 40 km per hour multiplied by time, again to be considered only in the hour over here. So 1 by 4 hours. So 40 into 1 by 4 will give you, you can cancel hour and hour. So 40 into 1 by 4 kilometer, and that is equals to 10 kilometer, right? So we have got the two distances d1 and d2. And we also have got time t1 and t2, so we can solve this over here. So d1 is given, we got it just now, it is 15 km from the solution what we have got, and d2 is 10 km, we can write over here 10 km, and the total time first is 1 by 4 hour, and again it is 1 by 4 hour. So 1 by 4, 1/4 plus 1/4 is like half, right? So this will become like 1 by 2 hour, half, and 15 plus 20 is 10 is 25 kilometer. So if you solve this, 15 is divided by 1 by 2, that is 15 gets multiplied by 2 by 1, and the unit will be kilometer per hour. You can see how the units are taken care of automatically. In physics, if you are converting it properly, you will always find the units will be correct. So here it is 25 into 2, that is 50 kilometer per hour, and that's the average speed. That's the average speed. Now this question is like interesting one. Why? Sorry, I wrote something wrong over here. This is average speed. Children, when they solve this question without even understanding, what they do, they take the speed as 60 and 40 and divide by 2, they get the same answer as 50, but they do not understand this argument. How can this be correct? Because if you go by this solution, you may not be correct always. This solution is true and it matches with the solution that we have done in the long process. So children think, why can't we do 60 plus 40 by 2 if it is giving us the same answer? I missed the unit. Well, this is what we need to understand. When can we simply take 2 speed and divide by 2? Okay, so I'll show you one solution again. This solution here, if you see, the time that we considered, the t1 and t2, the time is same. The time that the object is traveling in the first interval and in the second interval, the time is same, and that's very important. When we have equal time, then we can solve this question in a very easy way. And there is a small analysis for you on the screen. You can see either you find that the distance is same or time is same. In that case, we have a shortcut formula that can be applied. So in this particular question, you have got 15 minutes, and 15 minutes means time is same. So if time is same, in this particular case, you are free to apply the formula, that is x plus y by 2. If I am calling the speed in the first interval as x, and if I am calling this as x, and if I am calling this as speed as y, then you can directly take the average of the two like this: 60 kilometer per hour plus 40 kilometer per hour divided by 2, per hour divided by 2, that is 60 plus 40 by 2, that is 100 by 2, and that is 50 kilometer per hour. Now this is true only in the case where the time interval is same, okay? But if the time interval is different, in that case we have a different solution. The formula is 2xy divided by x plus y, where x is the speed in the first interval and y is the speed in the second interval. So you will find that the solution is in the next set, which I will be discussing in the next video. For now, I have a bonus question for you. The same question here is there, but I have just changed the time to 1 hour. You can see that in the first interval, the car is moving at a speed of 60 km per hour, and in the second interval, it is moving at a speed of 40 km per hour, and it is moving for 1 hour each. It is moving for time t1 is equals to 1 hour and time t2 is equals to 1 hour. So you need to calculate the average speed. So you can do the solution in two methods. The shortcut that you know is, since time interval is same, so average speed will be equals to, you can write the formula here, x plus y by 2, and this will be like 60 plus 40 divided by 2, that is equals to 100 by 2, and that is equals to 50 kilometer per hour. See, no matter whether it is 15 minutes or 1 hour, the answer is going to be 50 kilometer per hour, because time interval is same. Now, if you had done it by the long method, okay, by calculating d1 and like this, if you want to calculate d1 over here and d2 over here and then solve it, it is still going to be easy and same. You can see here d1 will be equals to, what is distance? Since the speed is 60 kilometer per hour, so in 1 hour it is going to travel 60 kilometer. You can multiply and check, and d2 will be equals to, the speed is 40 kilometer per hour and it is moving for 1 hour, so it means that it is obvious it will travel 40 kilometer. So from here you can see time t1 is 1 hour and time t2 is equals to again 1 hour. So from here you can use the formula, average speed is equals to total distance by total time. So total, I'll write here d1 plus d2 by t1 plus t2, and in this case you can see how the formula is coming, like this is 60 plus 40 divided by 1 plus 1, so you get the same answer, 60 plus 40 by 2, and that is equals to 50 kilometer per hour. Got it? So this is so interesting, you know, when time interval is same, the answer can be done in such a quick step. Now let's get to the question number 3. The question number 3 is based on Newton's 3 equations of motion. I hope you have practiced enough. Now, the moment you find the question is based on Newton's 3 equation of motion, the first thing that I ask my children to do is write the given information, right? Given, and you can make a column over here, u, that stands for initial velocity, v, that is final velocity, a, that is acceleration, t, that is time, and s, that is distance or displacement. So you should keep this table ready, and now as you read the question, you can put the information in the given column over here. So a bus starting at a speed, so starting means what? At a speed of 36 kilometer per hour, it means the initial speed is given how much? 36 kilometer per hour, attains a speed of 72 kilometer per hour. It means the final speed is 72 kilometer per hour in 10 seconds. This represents time. So time is given over here 10 seconds. Find the acceleration of the bus. So we can see we are supposed to find the acceleration, this quantity we are supposed to find, and calculate the distance traveled by the bus to attain the speed. We are also supposed to calculate the distance. So children, one thing you should know that in these type of questions, if you have got 3 information, then you can actually solve it. If there are only 2 information, then this information will be insufficient to solve the numerical. So you should keep in mind, the moment you have got 3 information, it means that you can find all the solutions. So first we need to calculate A. So in order to calculate A, as you know the 3 equations, you can use equation 1 as well. One thing I need to just tell you over here, let's see the bus starting from the initial point and moves in a straight road, right? So let us assume this to be the initial speed. So here this is point A and it is a point B somewhere in its journey where the speed became 72 kilometer per hour, and this is 36 kilometer per hour, and it took time as how much is given here, 10 seconds. So I am also representing the information in form of a diagram, and we are asked to calculate the acceleration while the bus is going from A to B, and also we are supposed to calculate the distance and displacement. In this case, distance and displacement is same because the bus is going in a straight line or a horizontal road without changing the direction. So in this case, distance and displacement is same. So we first need to calculate acceleration. So we can use a formula from the first equation of motion, or you can write using first equation of motion, we can write A is equals to V minus U by T. Since all the information is given here, we can put the value of V as weight. This is what children do in the exam. They just write here 72 minus 36 by the time given, that is 10 seconds, and that is going to give the wrong answer. So this is where I want you to stop. Why? The reason is you need to find the units. You are finding acceleration. The unit for acceleration is meter per second square, and for displacement you are calculating in meter. You should be very careful about the units. Now in order to find the acceleration in meter per second square, you need to convert this kilometer into meter and this hour into seconds. Unless you do this, you won't get the right answer. So how do I convert 36 kilometer per hour into meter per second? Now you know this thing, you have a factor. If you multiply this by 5 by 18, you'll get the answer as 10 meter per second. And if you multiply this again by 5 by 18, you'll get the answer as 20 meter per second. Now you can see it is meter per second, and then we can put the value over here. This is the mistake done by students when they are starting the numerical, and once they are practiced enough, then you don't make mistakes, I know. So this is 20 meter per second minus 10 meter per second. I can write meter per second outside over here, and then time is given here as 10. I'm writing here as second. So you can see here, this is how much? 10 divided by 10, and this is meter per second square. And 10 divided by 10, is it 0? No, it is 1. Please take care of this as well, because children in a hurry, they even write 10 divided by 10 as 0. Please don't do such mistakes, because you are going to use this acceleration in the seconds part of the numerical, and then if you don't do the calculations correctly, your further calculations are even going to be wrong. So this is the solution for acceleration. So we can put the value, we got it as 1 meter per second square. Now we are supposed to calculate the displacement. So to calculate the displacement, so we have got T, A and U. So we can use the second equation of motion. Using second equation of motion, I am focusing on calculation in this video so that you don't make mistakes. So the equation is S is equals to UT plus half AT square. Okay, so let's put the value from the given information. U is 10, don't write 36. The time is 10 again, plus half. A we have calculated as 1, so I'll write here 1, and again time is 10 seconds over here, so I'll write 10, but I need to put square on it. Okay, and since you have taken care of all the units, so there's no need to mention here meter per second and second over here, because the answer will automatically come in meters, because all the units are converted properly. So now here children need to take care of the board mass. This is 10 plus 10, and again this is a bracket over here. So this is 10 plus 10 is 100, and this is half into 10 square is 100, so this will be like 50, and 100 plus 50 will be 150 meters. So this is the answer. So it means that the bus actually covers 150 meters to gain the speed to 72 km per hour. So I hope the solution of this question is clear. It is super easy. You just need to take care of the units and calculations. Now coming to question number 4, This is the last question of the paper. It's a question based on graph, and as you can see here, the graph is velocity time graph. It is velocity and time, so it's a velocity time graph. The question says the graph given below shows the variation of velocity of an object with time. Fine. What is the acceleration of the object in last 3 seconds? Means 7. Okay, this is the last 3 seconds. We are supposed to find the acceleration of the object. Okay. So in the last 3 seconds, we need to find, here the speed at this point, or the velocity at this point, and velocity at this point. Let me call this point as B and C. Okay. So here this is the final velocity and this is the initial velocity, right? You can calculate using the slope method, or you can calculate using the algebraic method also. So in this video I am focusing on the algebraic method only, not the graphical method. So even though it's a graph, because from here you can actually figure out that your initial velocity u is how much? The point B corresponds to 8 meter per second. You can see it corresponds to 8 meter per second. 8 meter per second. And point C corresponds to 0 in the y-axis. You can see, if I see the y-axis, point C will correspond to 0. So V is equals to 0, means final velocity is 0. Means the object goes to rest. So, and the time is given already, that it is how much? From 4 to 7. So you can see here that t is equals to 7 minus 4, and that is equals to 3 seconds. So since you know u, v and t, you can calculate a over here. So acceleration a is equals to v minus u divided by t. So final velocity is 0, initial velocity is 8, and time taken is 3 seconds. The answer is coming as minus 8 by 3, and if you just divide this, you'll get 2.666 meter per second square. It is negative. The acceleration is coming negative, means that it is retardation. This is retardation. The object is slowing down from 8 meter per second to 6 to 4 to 2 and finally 0. So the object is finally coming to rest. This is retardation, or you can say negative acceleration. Now this is nothing but negative acceleration, and here the velocity is increasing 0, 2, 4, here 6 and 8. This is positive acceleration, right? So we have answered part 1. Now let us see the answer of part 2. The question says, what is the velocity of the object after 3 seconds? So this is 0, 1, 2, 3. So after 3 seconds, the velocity over here is, of course, constant. This is constant velocity because velocity is not changing, and the velocity remains constant from here to here. This is equals to 8 meter per second. So you can write the answer directly, no calculations required. So that's all for this video. We have done 4 questions. I want my children to practice like this at least 5 questions at least 2 times in a week, and I'm sure that if you keep practicing, then you can learn physics and start enjoying physics like me, the way I do it. So thank you all for this video, and I hope you all enjoyed. Till then, take care of yourself and happy studies. See you in the next video.